Of course, it's a pleasure to me to introduce a colleague who's going to give the next talk. The background of this one is we were involved in a number of, say, high-profile denial of service cases in the last year in customer environments, and then we saw the need to prepare something, to put together like what can you usually do about this, and there was a project from another customer which was an ideal opportunity to put together what we think are current strategies when it comes to fighting against denial of service attacks, and I'm happy that Oliver will present on this.
Yeah, thank you, Enno, and hello everybody. So, as Enno said, this talk is about denial of service attacks and how to protect against them. And we will see what this actually has to do with lasers. So just to be on the same footing, so a denial of service attack is basically an attack where the sole purpose is to get some resources or systems unavailable so that they are not reachable from the outside anymore. And this talk is basically focusing on three different things. So the first thing is why is actually this protection important? And I'm writing here denial of service protection. With denial of service, I mean when the attack happens from one computer, it's just a denial of service. When this is a distributed denial of service attack, then it's happening from more computers, more than one. The second point is what types of DDoS attacks are actually there in the wild. And the third point is how do I actually protect against these kinds of attacks? So why is DDoS protection important? Maybe you have heard of this operation, Operation Payback. This was performed by Anonymous. So they were not happy that Lazer stopped the support for WikiLeaks after WikiLeaks has published some important US documents. And so they thought it is a good idea to just perform a denial of service attack on Lazer.com. And what they actually tweeted here is that everybody should get your weapons ready and basically attack this site. So what do they mean by getting their weapons ready? This is actually what they use is the low orbit ion cannon. So this is a tool where you can just input here an URL. Then you click on the title of the talk, Imma charging my laser. And it basically starts the attack. You can configure here something like the payload, which protocol to use, so different things. So basically, they use this tool. And this is the first version, but later it was made open source, so there actually exist many different versions where you can input different things. For example, it's now easier to control basically these types of attacks because you do not necessarily need to put in here your URL. You can also put in the command and control server. And if you put in the command and control server, basically your client is controlled by some server somewhere, and it is coordinated in this attack, which makes this much easier. This is one example. There are, of course, other examples, like this DDoS for Bitcoin, which got quite famous in the last years because it targeted some German banks. And basically what they did, they wrote the bank an email saying, pay us this amount of Bitcoins, or we will do a DDoS attack. There was also, some years ago, this DDoS attack against Spamhaus. So Spamhaus is a non-profit organization which provides basically blacklists where you just put IP addresses on for example, servers that send spam. And after a certain hosting provider, the cyberbunker, was put on this blacklist, suddenly some DDoS attacks started, so you can maybe guess who could be responsible for this. But the interesting thing about this one is that we actually got some details about this. So because Spamhaus basically asked Cloudflare to protect their services, and Cloudflare actually provided a little bit of the chronology of this attack. And what we can see here, for example, so this is the bandwidth over the time that was sent just to the server and was going then through Cloudflare. What you can see here is basically we are here already in an attack. So this is everything already attack traffic. But we are here basically on a constant level of 100 Gbps. And what you can really see is here, you can like get this instant on attacks. So you don't really have time where you see this ramping up. You get instant on a large or a huge number of attack traffic. This is 300 Gbps attack. And I mean, when we compare this to the bandwidth of a few gigabytes per second that the usual data center has, then you really see this attack traffic can congest your connecting lines to the data center quite effectively. I mean, of course, this is attack traffic. The usual attack traffic that we see, I mean, if smaller sites are targeted, is only about 2 gigabits per second. What we also see here is the attacks usually last quite short. So it's not like they are going, I mean, this all is an attack, but if we just would imagine this attack is not going on like forever, this is only like a few hours. So you can have small, or you can have this burst in a large number of, or in large frequencies, which have these high peaks. So basically, to summarize this, why DDoS protection is important? It is important because there are many reasons why somebody could be mad on you or would like to try to attack you. As we have seen, there is, for example, blackmailing. It can be politically motivated hacktivism, as done by Anonymous. There can also be competitive advantage, or there's some hate crime because somebody doesn't like what you do. There are also script kiddies because they can. And I mean, it can also work as a distraction for other attacks that are prepared. For example, you have a DDoS attack going on here. Your IT security team is like totally focused on this attack. And in the background, there's also some data exfiltration happening somewhere else. And you don't really see this because you are just distracted. So what types of DDoS attacks are actually out there? I mean, this D is always in brackets. It can also be just a normal denial of service attack. Basically, you can put this into 3 different categories, and each of these categories also need different handling of how you mitigate this attack. So first of all, which is basically totally different from the other attack categories, is the volume-based attacks. These volume-based attacks is basically what you've have seen at Spamhaus. It's an attack where the attacker just tries to exhaust the bandwidth of the connecting line. The other attack category is this protocol-based attacks. What's happening there is somebody tries to exploit a vulnerability that is protocol-specific and tries to exhaust resources on the server. And if we exhaust enough resources, then maybe this server cannot respond to legitimate requests anymore. The third category is these application-based attacks. And there really one tries to find vulnerabilities in the application that are in the back end and tries to exploit them to have a denial of service scenario. When we look at these different attack types, then we see actually that they have different properties. Of course, first, of course, they are measured by quite different criteria. So volume-based is measured in bits per second, protocol-based in packets per second, and application-based more in requests per second. But what is more interesting is the difficulty of these kinds of attacks, because this tells us something about how easy it is for an attacker to perform such an attack. So the difficulty, basically, of volume-based attacks is quite low. You just try to send some, for example, large UDP packets in a high frequency to your target, which is basically, yeah, you don't need to think really much what is happening in the back end. Protocol-based attacks and application-based attacks instead are a little bit more difficult to perform because you really have to, basically you have to a little bit of know what is running in the back end so that you can exploit it. That's why these attacks are a little bit more difficult to perform. This goes directly with the level of customization. So these attacks have really to be designed basically these application-based attacks have, for example, to be designed for the application, while this volume-based attacks do not have to be designed for this kind, for some application. Also, the impact can be quite different because, I mean, this volume-based attacks, they congest your whole connecting link. That means if the whole link is congested, it means your whole data center cannot be reached from the outside anymore. However, this protocol-based attacks may take down some service, I mean, depending on what it is, a server or a firewall. And I mean, if the firewall has some network segment behind it that is critical, I mean, if the firewall goes down, then it's critical because this network segment is not reachable anymore. But depending on this, the criticality or the impact is lower than for the volume-based attack, where everything is not reachable anymore. It goes lower for the application-based attacks because usually only the application that is targeted is going down. And depending on the application, this can have a high impact depending on the money that's involved there, or it can have a low impact. Just to see this also from a statistics perspective, there's this worldwide infrastructure security report that is basically generated by Arbor frequently. And this, the data for this has been collected in 2015, but it came out in 2016. And what this shows us is basically what we have seen from this difficulty. So most of the attacks are volume-based attacks. And protocol-based attacks and application-based attacks actually are on the same level here, but are much lower than volume-based attacks. What you can see here is the numbers don't add up to 100%. I mean, I took these from the report, but it can be a rounding error, or maybe it's because what we can also see is that an attack is not always like, okay, it's a volume-based attack or it's a protocol-based attack. Sometimes it can be a mixture of different attack vectors. Actually, what was shown in this report is that like around 50% of the attacks use different attack vectors. So there can be multiple attack vectors, and then it can be quite different to mitigate the attack because you have to deal with different attack vectors. Actually getting to the volume-based attacks, I just want to show some examples for each of these categories so that you get maybe an understanding what's happening there. So in volume-based attacks, what you can simply think is there's one attacker who has a laptop and he has an uplink with 5 megabits per second, which is quite high for a single attacker, but nevertheless, he sends attack traffic to some target, which is here going through the internet, and 5 megabits per second come at the target. Of course, that's not how it is done in reality. In reality, we have here our attacker, and he has either bought on the black market some botnet, or he has compiled the botnet himself. He's controlling the command and control servers, and these servers just tell the infected computers on this botnet to send attack traffic to the target, and then he can really get up to higher bandwidth, like 2 gigabits per second or something like this. But actually, this could be a legitimate attack, but actually you can also make it worse. There are these reflection attacks where you can use, for example, DNS servers. So what you have here is you have an attacker, and the attacker sends a small request, for example, a small DNS request to an open DNS resolver, and the response to this request is quite large. So this factor can be like a factor of 50 between request size and response size. But what you want to do here is you want to spoof your source IP address so that actually the response to the request is not sent back to you, to the attacker, but to your target, so that here the large response is actually sent back to the target. And I mean, okay, this means the attack is depending that you can spoof IP addresses. How likely is it to spoof IP addresses? There is actually this project, spoofercement.org, which collects data since 2005. And this data is basically from 2013. And what they have shown is, I mean, they have made a small program. You can install it in your environment, and they just test if IP address spoofing is possible from your infrastructure. What they found is that around 25%, so around 1/4 of all autonomous systems allow IP address spoofing. I mean, the number I would say is going back, but just to have a size or a scale for this. So we are speaking here about some 1/4 of all autonomous systems, and so basically this IP address spoofing is possible, but you do not only need to use DNS. You can also use other things. I mean, for DNS, this was, for example, used in the spam host attack. You can find servers that basically allow this kind of attacks, but you can also use other UDP-based services that allow this amplification. For example, this NTP servers can allow this. If they have enabled this monlist request, monlist just, if you request this, monlist will just give you back the last 600 IP addresses of the clients that have connected to the server. So this is a huge response. And then basically you can also use this in an attack. And there are other protocols that you can use. One thing that is important, this is UDP-based amplification. I mean, we want to have IP address spoofing. That means we cannot have a handshake at the beginning, like in TCP, where you would have to need one fixed IP address in the complete handshake. So that is why it only works in UDP. So IP address spoofing is basically prevented by the TCP protocol. Of course, the SYN-ACK in the TCP protocol is of the same size than the SYN request, so you also have no amplification there. So the question is, how are you not a part of the problem? So basically, you should check your UDP services. That means DNS servers should not be configured as open resolvers. That means if they are on the internet, they should not answer requests for any domain. That means if they would, they could be used for this kind of attack. And the US CERT has given some information about this in this advisory. And there's also this open resolver project, which has data from 2013, where they just collected information on open DNS resolvers. So they scanned 33 million DNS servers, and they found actually at this point of time that 28 million were vulnerable or allowed this kind of attack. I mean, the number's also going down, but also just to get a feeling for this. And the same holds for the NTP, the monlist comment on NTP servers. There's also an advisory by the US CERT, and there's also an open NTP project. What else can be done? I mean, IP address spoofing should be prevented. I mean, from my opinion, there's no real reason why IP address spoofing should be possible. And there are actually two best common practices that that describe how you can implement this. And this BCP 38 is basically describes how you can perform ingress filtering of your IP addresses. And if you have a multi-homed environment where you have basically can have different ISPs or some asymmetric routing structure, then you can use BCP 84. And these are basically also described in these RFCs. So this was about volume-based attacks. Now we come to protocol-based attacks. And I just want to present something simple here because actually some devices are still vulnerable to this. So here we can have, for example, a usual TCP SYN flood. So the usual TCP handshake goes like this. I mean, you send a SYN packet to the server sends back a SYN-ACK packet and waits till the client sends back the ACK packet, and then basically the connection is established between server and client. But what happens if the client just sends a large number of SYN packets? The server, of course, sends the SYN-ACK packets, and the client does not respond to these packets. Then the server will just wait till these ACK packets are received. But the client or the malicious client never sends these ACK packets. So the server is using up resources for waiting on these packets, but they never come. And this could lead that the state table which is used to just have these resources is filled up, and more legitimate requests cannot be served anymore. So what can you do against this? So there are basically so there's an RFC describing what you can do. For example, you can activate thin caches, which is basically you do not store the full information of the connection state in your table, but you only store parts of it in a hash table or via a hash table. And only when the full connection is established, then you put this information back into the full state table. That means basically with the thin caches, you reduce the resource consumption and only have the full resource consumption when the handshake is completed. What you also can do is you can enable thin cookies. What you do there is you do not store the state into the state table, but basically you put it inside of the packets that you exchange between client and the server. And by doing this, I mean, there is some disadvantage in quotes. By doing this, you cannot use some TCP options, for example, like big window sizes or large window sizes. However, you have to think about this. I mean, this mitigation measure, so thin cookies, will only be activated when you are under attack. So it's better that that the service is functional at all than that it's not functional. There's also something called TCP cookie transactions. Basically, this has experimental status, but this is basically an extension to TCP where you just have a client, basically a client extension and a server extension that these cookies can be, basically transmitted inside of the packets. And however, this has to be implemented also at the client side, so it has to be supported by the client. And with this, we come to the last category, the application-based attacks. Of course, application-based attacks are highly application-specific. That means it depends what is running on the back end. What you can have there is, for example, or what is quite general, you can have computational expensive operations, something like a database lookup or PDF generation on the back-end side. So these are quite expensive, and if an attacker tries just to perform many of these requests, then he can consume the resources that are reserved for the application, and the application cannot serve any more legitimate requests. Of course, what you can also do is you can try to exploit vulnerabilities in the application just to crash the application, for example. These are highly specific, but there are also, for example, some general attacks that target web servers. The so-called slow header attack, which is implemented by a tool called slow rollers, for example, or the slow post attack. So what are these attacks in a little bit more detail? So basically, the slow header attack tries to open up over time many HTTP connections to exhaust the resources on the web server. And how does it do this? So basically, you open up a connection, but you do not send the full request, the full HTTP request. You just send partial headers. And from time to time, you send more bytes and more bytes. So after 1 second, you send maybe 1 byte more. After another second, you send 1 byte more, depending on the timeout of the HTTP request. And basically, by this, you just hold the HTTP connection open. And if you open from time to time new connections, then you basically get a large number of opened HTTP connections. And this can really get your resources from your server, from your web server. But it has to be said that this only affects the web server and not the other services on the server. I mean, it can sometimes, but usually it only affects only the web server. The slow post attack is quite similar. Basically, what you do here is you don't use the headers, but you use the data in a post request, and you just incrementally send more data, so to say, in the body of the post request. So you can do this by defining a large content length header in the header field, and then you basically just do it like the header attack, like the slow header attack, but with the data there. So what can be done about this? I mean, the one thing you can do when you have like a beefy server, you can increase the maximum number of concurrent connections. But what you would also like to do at the same time is you have to limit the maximum number of the concurrent connections that are coming in by the same IP, because this connections would mean that they come from the same attacker. What you can also do is limit the time span that a client can stay connected. This means, in more detail, that a request should be completed in a certain amount of time. It makes no sense that you just have 1 byte sent, and the request is never completed, but you can say the whole request must be completed in like 30 seconds. There exist special modules for certain web servers to implement this. For example, for Apache, there exists this mod rec timeout. It's implemented by default in the current version, where you can define these parameters, but you can also use the model for quality of service to define these parameters and play with them for your application, so to say. So basically what I've shown you a little bit is here different attacks, and I've shown you some mitigations for these kinds of attacks, which were really like on a micro scale. But when you want to go into a larger scale, when you want to tackle it maybe from a corporate perspective, where you have a big data center, then I mean, of course, many things have to work together in order to implement all of this. And what I want to present you here is actually a strategy which has many layers, going from the application to basically different layers, all up to the operations. I mean, we start here slow. That's why here's the tip of the pyramid, and we get here bigger and bigger, where we are at the network layer, and then we are basically at the ISP layer. And what you can do here at these different layers, I will basically describe in the following. So starting with the application, of course, what you want to do is you want to have a good patching procedure, because some of the patches are really only there to mitigate some denial of service attack. If you do not, basically if you develop the application yourself, then you want to have a secure development lifecycle. That means that your secure coding guidelines should also implement features on denial of service prevention. In more detail, that means what you want to have is, if you have this critical operations like a large database lookup, then you want to have authentication and authorization for this operation, so that not just anybody can perform these operations, but you know which user has performed this operation. And of course, you also want to have a security assessment of your application with denial of service in scope, because if you have just a normal pen test of the application, it means if you want to test for denial of service, you would destroy or crash the application. That would mean that your normal pen test cannot go on. So it really has to be focused on denial of services security assessment. To give you some war stories, what can happen, for example, I mean, usually when we have a web application test, we use Burp, which was shown in the last talk, to just get a large number of session IDs, for example. We put them, we get like 20,000, we collect them quickly, and we do some entropy tests on them to see if the randomness of the session ID is good enough. However, some applications just crash when we just pull the session IDs, because actually the session ID, or the allocation for the session ID, uses up resources in the back end. And I mean, a session ID has a timeout of like 10 minutes or 15 minutes. That means they are used up for this amount of time, okay? And if you have not a reallocation, or if you do not drop sessions where no data is sent anymore, then I mean, you can use up all your resources on the server side and your application can crash. And that's why basically, even if you don't look for denial of service, you sometimes can get these denial of service scenarios. Going further up, we are at the server layer. Of course, I've already told you, hardening of server systems is important. So you have to make sure that your devices, for example, your servers, or other devices are not vulnerable for the SYN floods. You can perform web server hardening against the slow header attacks or in post attacks. So these all go in here in the hardening. And of course, a security assessment should also be done on a regular basis for server systems. And this should include vulnerabilities which have this denial of service in scope. So going one step higher, we are now at a load balancer level. I mean, the load balancer is basically, it can have some options that can help you with denial of service attacks, but it depends, because we have to see if it really only is a load balancer or it can have more options, like more like an application delivery controller. And what you can do, for example, so SSL negotiation is quite a computationally expensive operation. What you can do is, on this beefy load balancers, you can basically do the negotiation there, which is called SSL offloading. What you can also sometimes do is to test if a human is sitting at the client side. How can you do this? You can, for example, if the load balancer has the capability to inject HTML, for example, or JavaScript or something like this into your request, you can just send JavaScript to the client, perform some calculation there, see if it gets calculated, and let it send back to the server just to see if the client side could evaluate JavaScript. And if it cannot evaluate JavaScript, it can be an indicator that it was a headless browser or something else, so something that is not really like a browser that a human would use, but it's only an indicator. There's actually a white paper by Zans where a little bit of this is described in more details. Coming to the firewall, I mean, I had it in the strategy, but I have to mention here that, okay, a firewall is basically good for restriction of access, but for denial of service, it can be a part of the problem, because there was a talk like a few years ago by Adam Zen, where he has evaluated some of the firewalls, and he always found that they are, after a certain while, vulnerable to a large number of SYN flooding. So if he has like 150K, then like certain devices would go down. So basically the message is here that you should check if your devices are vulnerable against this kind of attack, and if they are, can they be exchanged? But this basically is not only a problem of the firewall. All devices that keep some state can be vulnerable to this, especially if they keep the state and process it somewhere in software. Then they can really be vulnerable to this type. So the conclusion is firewalls rather pose a problem than a solution to denial of service attacks. So going one step more, higher, what came up in the last years are dedicated appliances that provide protection against basically, first of all, denial of service attacks, but sometimes maybe also against distributed denial of service attacks. So what they basically do is you put an appliance in your infrastructure, you can define certain rules there based on some protection groups, and based on how fine granular these rules is, they filter attack traffic routes out. And when you set up this appliance, basically what you do here is you first go into some detection-only mode. That means you do not filter out any attack traffic, but you just see which attack traffic would be filtered out. And then you can configure your appliance such that basically to the traffic that you see on your network. Another story for this, so I once had a project where I just was given one of these appliances. I was on the client side, and I had this basically a random application at the server side. So I could decide which application I had at the server side. And the appliance wasn't really configured for this application. And that means we always found some loophole through the appliance in order just to make a denial of service attack of the application. So the message is here that it does not work to just have this appliance. It really has to be configured for your environment. This includes you should generate some kind of protection groups and rules for these protection groups. So protection groups are groups of similar applications that have similar traffic patterns. Another question is, where should I place this appliance? I mean, basically, you should place this appliance next to your edge routers because it should protect all your other devices against denial of service attacks. I mean, you put a lot of trust into this appliance when you put it in next to the edge routers. That means you should also develop this trust by pen testing, for example, this appliance. But basically, this is the optimal place where it should stand. What you also want to think about is, do you want to use this as a hybrid solution? Meaning, often the vendor of the appliance can work together with a dedicated cloud-based scrubbing center where also some filtering can be done. And if these are by the same vendor, then you have some information exchange that can maybe be used to have a better protection. Another point is SSL or basically encrypted traffic. Do you want it to be inspected by this appliance? So basically that means you have to basically decrypt with this appliance the traffic. Sometimes you can do this, sometimes you need extra modules. This is a decision that you have to make if you want to do this by this appliance. If you don't do it, of course, you cannot look deeply into the application-specific part of the traffic. And last but not least, you have to decide how this going live process has to be done, because going live is always a special point with this. I mean, at some point you have configured your appliance and then you turn it on, so to say. But it can be that you drop legitimate requests. That means you have to have visibility of your infrastructure if the services are running or if they are not running. And I mean, if you see that they are not running, then you can basically revert back quite quickly to the state where it's not been used. But for this, you have to have visibility of your network infrastructure. To configure your appliance, basically, this is only some snippet of this. I mean, there's going a lot more in there, but some basic stuff that you can do is, of course, you can define some blacklists where you have some feed, which can give you some uprising botnets, which can be seen by the different vendors. And you should have also some whitelists for the customers so that you do not block them. What you should also include is the IP reputation. What you especially can use there is the geo-IP, because often it is like this, that your customer base is just sitting, for example, in Europe. And suddenly you see a lot of attack traffic. I mean, I now have to choose a country, let's say, out of China or something like this. And then you want to block basically the traffic based on this geo-IP. What, of course, you can also do here is make this human checks, which you sometimes can also do on the load balancer. What can often be done there is you can also check the compliance to the TCP protocol. So send some wrong answer to a usual TCP handshake and see what is happening there. That can give you some indication of if a human is sitting on the other end. Of course, to have application-aware protection, you need to define your own rules with some regular expressions, for example, based on your applications that are running there in order to just efficiently filter out the traffic. And what you have to think about is, do I need configuration changes for special events? Meaning, if you have, for example, if you are selling something and you have some flash sale and you know that more customers are coming at some certain point of time, then you have to configure your appliance especially for this. Yeah?
Do you have any experience using IP reputation and geo information to block traffic? Is this something usable?
It is when the feed is good. So you have to have, I mean, it depends when, I mean, you have to have, basically when we come to the scrubbing centers, then you see that you have, data centers around the world, which can see basically a more distributed view of the whole traffic going on in the world. If you use this and see that there's something strange going on in this part of the world, so you are near to the source, then it can work. But I mean, it highly depends on the reputation list. So I have not gathered any information how, so I have not so much experience with this. I have not configured it myself, but it depends on the list, and I think it should be you gathered like this with a distributed view around the world. Only if you have this, then you can do this. But apart from this, GeoIP, I mean, you can use just to block unwanted traffic from other countries. This depends, of course, what you usually see in your environment. So if you see like traffic from all around the world, usually then it doesn't work. But if you only have a very limited customer base, then you can use this.
Or geographically bound.
Yeah, exactly. So going one step further from this appliance, I mean, I already told that IP address spoofing should be prevented on the network layer, basically. Then you should have this segmentation of your network into different protection groups, which have different traffic patterns, because often what is on the next slide, you need certain groups which are located in a certain IP address space just to push or to say, for example, to a scrubbing center, I want to protect this /24 IP address space, and you better have this same group in the space because you do not want to have your whole IP address space protected, because sometimes the cost can depend on how large these groups are. And of course, you can use anyway your existing segmentation, because segmentation is always good to have some separated structures in your network depending on functionality. But basically this should be done. And another question is for the network, is my appliance, if I buy something, do I put it directly into the traffic? So do I put it inline, or do I put it out of path so that it's not seeing directly the traffic, but gathers, for example, information via net flow from different points of the network, and only if it sees an attack, it will be put into the path and can filter out the traffic. So these are decisions that you can have to make from a structural point of view. And of course, which I also mentioned, this monitoring of your applications and systems is quite important, because I mean, often these appliances can provide you with some protection against an attack, but I mean, if you don't know if your services are running in the back end or not, you don't know if your appliance is really working quite efficiently, because sometimes it can be that something is going through and your appliance is down, so you have to have some check if your service is down in the back end, and you have to have some check that your service is up. And going further on, so basically here's a little split, because now we are basically leaving the data center. And what we have done before basically only mitigates really non-volume based attacks. So what you can do with the ones before was limited, so to say, to protocol based attacks and application based attacks. If you want to have something that helps you against volume based attacks, I mean, you have to go to some point of your upstream infrastructure where you have enough bandwidth so that you can implement something there, so that you can filter it there. Okay, one point for this would be the ISP. So some ISPs actually provide you with some service that gives you this protection, but often, in my experience, it's only based on some existing appliance sold by some other vendor, which they implemented into their infrastructure. So the main problem basically is here that the ISP is not really, so the main job of the ISP is not your denial of service protection. That means they may have some knowledge about this, but they may not be the specialized persons for this. There can also be some operational issues. I mean, if you have a single ISP, everything is good, because you can just configure your solution at the single ISP level. But if you have a multi-home solution where you have maybe more ISPs, then you have to configure your solution at the one ISP, you have to configure your solution at the other ISP. They have to work together. If you have asymmetric routing, then it's maybe not so easy. So there can be some operational overhead when you have a multi-homed environment. And one thing I want to note here is that usually or often remote triggered black hole filtering is something that is mentioned to be a solution to these problems at the ISP level. So remote triggered black hole filtering is basically that you push route up to the ISP where you say, okay, all my traffic that is going to this IP address space is just discarded, and it's basically a null route at the ISP. So none of your infrastructure will see this IP, this traffic anymore. But basically, this only completes the attack because you are dropping all the traffic, not only the attack traffic, but also the legitimate traffic. I mean, you can, it can provide a last point of resort if another IP address space in your infrastructure is going over the same link. Then, I mean, if you drop the traffic for one segment and the other is then up because this traffic is regarded and the link is then cleared again, it can save your services on the other segment.
One question here.
Yes?
Actually, for the service being attacked, this is more or less I give up.
Yeah, exactly. So the service that is attacked is...
The attacker was successful in that case.
Yeah, exactly.
Easily used in the case to propagate internal, let's say, subnets to let's say, to BGP peers, so that within your AS, the services are still reachable. Isn't it the case here?
Within your AS, yeah, within your AS you can reach the services because if you have a route, I mean, yeah, in your AS you can reach it. Yeah, but if you are going from external, then the traffic is routed. Yeah, of course. Depending on the service, I mean, this can have critical consequences or not. I mean, if you
especially for machine-to-machine communication, this
Yeah.
can be very important.
Yeah. Okay. So we have seen one can basically implement some solutions at the ISP level, but I mean, one can also go to some other provider, for example, a cloud-based scrubbing center. So what you do there is basically you reroute the traffic through this cloud service. This cloud service, I mean, at the end they do something there. I mean, it depends on the vendor how much they tell you about this process, but they filter the attack traffic out in the case of an attack and only send the clean traffic, the good traffic, back to you. And how is this done? They basically have data centers around the world who filter the attack traffic, basically distributed around the world. And what they do is they basically hijack your IP address space in the case of an attack, reroute the traffic through them and filter it. What is good about this is that they filter the attacks next to the source. That means this can sometimes prohibit IP address spoofing, because if I see that my packets are coming from one IP that is not that should not be sent from there where it is geographically located or structurally located, then I can see, okay, this must be spoofed traffic, and I can drop it, or I should process it in another way. What's also good about this cloud-based scrubbing centers is that they basically provide sufficient bandwidth to deal with the large attacks. I mean, we have seen for the spam house attack, it was like a peak size of 300 Gbps, and usually depending on the scrubbing center, they provide you like a bandwidth of terabits per second, or so 1 terabit per second or 2 terabit per second. So this is enough for this large DDoS attacks. But of course, you have to keep in mind the traffic is rerouted through third-party infrastructure. So it depends on if you really want this. But I mean, from the implementation details, you can also do something there. So if you do not want to reroute your traffic all the time through the scrubbing center, you can have this on-demand solution where you only activate this scrubbing center in the case of an attack. Of course, you have to somehow see if you are attacked, meaning, I mean, you can have some simple rule when you say, okay, if my line is congested by like 50% or something, or 60%, then I will just proactively activate my scrubbing center. You can do this, but yeah, you would need to see if you are attacked. You can also have this always-on solutions where the attack traffic is basically always sent through these solutions. I mean, this is usually not done for big data centers where you have a large IP address space, but rather for like a single homepage or several homepages. The rerouting of the attack traffic, of the traffic, it can be done by different means. For example, you can have a BGP-based rerouting. What you often need is there at least a /24 network that you announce that should be rerouted, or you can have a DNS-based rerouting. But for this DNS-based rerouting, there are some complications because first of all, I mean, if you want to have it on demand, DNS entries do not converge so quickly over the world, so it can take hours or days so that this would be activated. But for BGP, it's like a few minutes and then it's converged, and then basically the rerouting begins through the scrubbing center. And also, I mean, what happens if you know the IP of the services that are hanging in the backends? Then you can just basically go past the DNS entry and just go via the IP directly to your service. That means anyway, you would have to have some origin protection, for example, also via BGP, so that that your IP address cannot be contacted directly. Another question is, how do I activate this scrubbing center? Is it okay if I activate it over the line that is attacked? I mean, that should be cleared, made clear in advance, because if the line is attacked and I want to activate this and somehow it's a stateful protocol, which I activate this, because, for example, it's like so it's a web interface, yeah, and I cannot reach the web interface through my my congested link, then I have won nothing because I cannot activate this. Or should I have a dedicated line where I activate the scrubbing center with? One other question is how to send the clean basic traffic that I have gotten back to the data center, because I mean my IP address space has been hijacked, so somehow the traffic has to get back to me. What you can actually do there is you can make, for example, a gray tunnel, or you can just use the leased line. And the last question that that one can have is, what about encrypted traffic? I mean, yeah.
What's the current best recommendation for IPv6 /48?
For IPv6, so basically, first of all, IPv6 only has like a very minor attack so it's like 4% of the attacks are going over IPv6. I don't know what's the current best common practices, but I would guess, yeah. Okay. So the last point we have to think about is the encrypted traffic. So do I really want to have my to decrypt traffic in the cloud? The last point is operations. Of course, everything has to work together. So there are actually 3 points of times for these operations: before an attack, during an attack, and after. And I mean, before, you have something like you have to configure the appliance, you have to document it, but you also have to have a good incident response plan so that all of the responsibilities are basically well defined. And this also means that you have a dedicated team for this, because I mean, in a denial of service attack, you have to have a team with the right psychological mindset. You always see immediately what happens if your service is down, so there's some pressure on you, and you have the right people for this. And I mean, during an attack, it can be that I mean, the people should act according to their responsibilities, but it can be that you have to reconfigure some of part of the appliance to basically mitigate some of the attacks. And of course, there's after. So, do I want to have some? Should this attack have some legal consequences? So, who should I contact in order to basically report this kind of attack? And who do I need to contact in order to report that the attack is over? There's a document by the third EU where basically this operational processes are described in a little bit more detail. So to come to the conclusion, basically, mitigation measures depend on the denial of service attack type. What I mean with this is volume-based attacks are filtered at a whole different level than, for example, protocol-based attacks or application-based attacks. Protocol-based attacks and application-based attacks you can filter at your on premise, but volume-based attacks you have to implement something upstream where you have enough bandwidth. Defense against these attacks is complex. That means it's not just working to take one appliance and just have like the magic solution. I mean, it has to be operated. Maybe it for this volume-based attacks, it has to work together with a cloud-based scrubbing center and so on. So you have to have a strategy based on your infrastructure. So you have to evaluate what fits for your infrastructure. How many services do I have? What needs to be protected? And this also goes into this. Build solutions, do not just buy them. So again, you cannot just buy the appliances and put it there. It will not do magic. It has to be configured for your environment. And the last point, I mean, the processes around all of these need to be well defined so that everybody knows which responsibilities he has in the case of a denial of service attack. But I mean, all of this now was like a huge strategy. What can I do in the case of an attack? But to get it down to 2 points, I mean, where should I begin? When we think about the beginning, what I showed there, I mean, this volume-based attacks, they have a high likelihood and a high impact because they can really congest your line to the whole data center. So it is really essential that you are prepared for this. So from a risk assessment point of view, you should start there. And the mitigation measures, okay, you have to implement something upstream, cloud or ISP. Has to be decided basically by you what you want to do there and who you trust of these cloud-based providers. And second of all, I mean, then come the protocol and application-based attacks. They have, depending on the application, for example, it depends what likelihood you have that such an attack can happen. And the impact also depends. But there you can, I mean, use, for example, one of these dedicated anti-denial of service appliances. I mean, you could also build the solution yourself, but this, again, is not foolproof because, I mean, you would have some guys who can do this, and there's some operational overload. And it's easier from the operational perspective to just see if an appliance fits for your infrastructure and have the guys sitting on there and basically configuring this appliance for your infrastructure. And of course, for this, you also need to make sure that you are secure applications and that you have secure application and servers, because it would be bad to just tell the application guys, okay, we have this box here. I mean, you do not need to worry about denial of service attacks anymore. No, it should also be implemented on the application side so that you have different layers where you can protect this. And basically with this, I'm finished, and I thank you for your attention.
Thanks, Oliver. Given we went a bit over time, I suggest having 1 or 2 questions. I mean, you are here, full conference anyway. Are there any questions right now? There is one over there.
One question.
I'll give you the mic.
One question regarding, you mentioned that there should be a tailoring or configuration of the appliance according what is protected behind it. Mm-hmm. In a huge environment which is protected, that can be a never-ending story. So do you have experiences with that?
Basically, that's why you have the simulation mode. Yeah, it's basically like sitting there for like 2 weeks, 3 weeks, 4 weeks, just seeing what is happening on your network, configuring basically your rules, and see if nothing of the legitimate traffic that you usually see is getting dropped. It's basically done like this. So it's not like, yeah, it's the baseline.
Yeah. Okay.
So.
Okay.
One more question.
I think one of the things that could help you is also using CDNs to deliver static content so that you reduce load on your side. Yeah.
I mean, yes, it can help, but of course, as the name says, it's only static content, and
Exactly,
usually the
yeah,
money is made by
exactly.
something that is dynamical, so it does not protect the critical
Exactly.
services. So yeah.
That's why it helps.
Yeah, it can help, but only.
CDN providers also have scrubbing centers.
Yeah, yeah, but
One that has which I know a big one. Yeah. They have.
yeah, but in the original sense, if it's only static content, I mean, if they only provide static content, then I mean, it also only helps for the static content.
Okay. This is the very last one, but
That's not a question, just a remark, or maybe something you could look into. I think that you should go and see some of the ISPs out there, because they are daily managing DDoS up to 200 gigabits per second, mostly for gaming purposes, because when you play on Counter-Strike and everything, some people get your IPs and then they will DDoS you. So even if it's not really, well, you think it's not really the job, they have a lot of ISPs, large ISPs, have a scrubbing center, but they don't really publish about it. But maybe if you go and see some of them, because they have a lot of, and because some of their equipments are the only one able to withstand such traffics. When you go above 300 gigabits per second, then, you know.
I mean, I'm not saying that you cannot implement this at the ISP level, but often they just use existing technology from one of the big vendors that provides this denial of service. And then the question is, okay, should I just take the scrubbing center that's also provided by this provider, which just made the appliances himself, or should I go to the ISP? I mean, okay, this is a question to which ISP you go and which ISP you have. Yeah.
thanks again, Oliver.